Hello everyone, and welcome all of you to the episode number 14 of our project discussion series. And as you all know, it's a platform where we discuss uh, projects, we discuss problems, and we share ideas amongst each other, and we learn from the experiences of fellow engineers. So, welcome to this episode to those who are watching this live and also would be tuning into YouTube to or LinkedIn to watch it later. So, before I begin, I hope my voice is all good and you can see me well. Yes, good. So, what is going to be the agenda for this episode? Let us see what is the agenda for this episode going to be. So I'll quickly bring it on the screen and what we are going to discuss. So we will start with a comparison of flat slab with drops and flat plate systems. These two systems, which are quite commonly used these days, that will be the first point of discussion for today. Then we will discuss a very interesting topic which I felt we should discuss, and that is how to work as a freelance structural engineer. So many of you whom with whom I interact, many of you also work as freelance engineers. So how to develop an ecosystem for it, how to work as a freelance engineer, that is what we will discuss in the second segment. And in the third segment, we will meet engineer Ishita Kalsi from Mumbai, and uh, she will share her experiences of working for big infrastructural projects. So that is the agenda for this evening. I hope we will have a good time discussing all of these. So without wasting any further time, let us get started, and I will bring on the first point of discussion, which is going to be a comparison between the flat slab with drops, comparing it with flat plate systems. So before I can share my screen, any one of you knows what is the difference between these two? What is the difference between flat slab with drops and flat slab and flat plate systems? Yes. Anyone would like to comment? So, Mr. No one. Okay, I think most of you know it because it's quite commonly used these days. So we'll just dive deep into what it is. So as you all know, slab without beam systems are quite popular these days, and we have covered some different aspects of flat slabs in one of our earlier episodes also. So why they are quite popular? Due to, of course, their easy construction and because they are aesthetically pleasing. They have functional advantages due to the ease of service lines which can be taken in a flat slab. I would say slab without beam system. So because of its uh, ease of service lines that can be taken through them, they also do have functional advantages. You get good clear height. So all these issues make slab without beam systems quite popular. So what are the different slab without beam systems that you might have seen? So you might have seen, I think two alternatives most of you would have seen, and that would be slab with drops, with drop panels, and flat slabs or flat plate systems. Mr. Abdul Rahim is saying in Gulf, he's joining us from Bahrain, and he's saying in Gulf, PT flat plates are commonly used. Very good. Yeah, in India these days also you see a lot of PT flat plate systems being used, and flat slab with drops also being used quite commonly. So here the topic that we are discussing, it would not be considering the PT slabs or PT flat plates. All right. So I think all of you know a quick cross section would seem to be something like this, that in a flat slab with drop, you will have a drop panel below the slab, and on your right, you can see a flat plate, so which is absolutely flat. Now, why do these days architects don't even prefer this? So this is also not preferred these days. right? You will see most of the architects will insist you to use a flat plate system. Okay, so whether this flat plate is really a good system or it has some disadvantages, is it too costly, all those things we are going to actually discuss today. So before I move, anyone has any thoughts which of these two systems is better? If you have to go for a slab without beam, then flat slab with drop is good or flat plate is good? What do you think? Yes, anyone has any thoughts? Okay, I think our audience is not less today. Anyway, okay. Why? First of all, why drops are required? Why did we require to provide drops? First, we need to understand that issue. That why drops are required. I think most of us know it. So drops are required mainly to control the two-way shear stresses and to control the punching, uh, the issue of punching in your slab without beam systems. Okay, Mr. Shubham is saying drop panel, so slab with drops is good, and Mr. Abdul Rahim is saying for architectural and MEP requirements, MEP sorry, flat plates are good. Mr. Rahul is saying if punching is not an issue, then flat plate is good. Okay, let us see. But punching, of course, is will always remain a problem. I mean, uh, uh, punching will always remain a problem. Mr. Chinmay is saying, I think pure flat slab is not good for large spans. Okay, so why drops were required? So drops are not only required to control two-way shear, which is the most critical limit state in your slab without beam system, but of course drops also help you to provide control against deflection, and also because of these drop panels which have a large stiffness, so you might have seen the behavior that they attract a lot of hogging movements, thereby restricting the sagging movements in the midspan. So therefore I have written that they also help in the redistribution of flexural moments. So drops are not only provided to control shear failures, but they are also provided to control deflection and to help better distribution of movements. So that's why drops we provide. Now, what happens if drops are not provided? So, whatever the advantages of drops were, now you will not be able to take use of them because now you are not providing drops. So, for example, if you are going with a flat plate, then this is the scenario you are looking at, that drops are not provided. So, what happens? Let us see. So when drops are not provided, the overall slab thickness has to be sufficient to cater for the flexural stiffnesses and control of deflection. Okay. So earlier, what you were doing, that you were locally thickening the slab wherever there was a column. There you were thickening the slab to control the two-way shear stresses and also to control deflections. Now what you will have to do, if you don't want to provide the drop panels, you will have to uniformly thicken your slab. Are you getting it? See, you cannot avoid punching. So what will happen? You will have to uniformly thicken the entire slab in a flat plate system. So while you were quite okay with this type of a configuration in a flat slab with drops, now you have to add this extra because you wanted to have a dropless system. So therefore, you will have to have a overall slab thickness in such a way that it is sufficient to cater for the shear stresses at column locations, and it also helps you to control the deflection. And of course, what will happen, because now you have to provide a uniform thickness without drops, obviously you will have to provide a larger slab thickness as compared to the situation when you have provided drops in the column region. Okay, I hope this is clear. And because of the larger thickness, because now instead of providing a sleek system with drops like this, you are providing a uniform large thickness overall. What will it lead to? It will lead to high self weight of the structure. Do you agree? So the larger thickness adds to the sulfate of structure. What will happen if it adds to the sulfate of the structure? What happens if your system starts becoming bulkier and bulkier? What will happen? So the columns have to take more and more loads, right? The columns now start becoming, or you have to increase the sizes of columns so that they cater to this additional load because you are providing a uniform thickness. So larger thickness adds to the sulfate of structure. If your sulfate is more, so it's a vicious circle that you are now uh, trapped in. So now because your sulfate was more, what happened? That you needed a larger, the seismic weight of your structure increased because larger sulfate, larger seismic weight. Now, larger seismic weight would mean more earthquake forces. More earthquake forces would mean you need larger column sizes. Are you getting this? You are caught in a vicious loop right now. I hope you are able to appreciate what I'm telling you. So, so thereby the structure then needs to be designed for larger earthquake forces. Not only this, as I told you, the increased sulfate leads to increase in column sizes and the reinforcement. So not only uh, the seismic weight increases, even the entire sulfate of your system increases, thereby adding to the uh, requirement of larger columns. And if your overall loads have increased, of course you will require larger substructure sizes. So imagine you were doing an isolated footing, and now if you have to do isolated footings for larger dead weights, of course your sizes will increase. Okay, so this is a loop that you are caught in. Not only this, if drops are not provided, let us think from the seismic perspective also, that having drops, do they help you in providing additional seismic stability? So obviously this entire system in itself, that is slab without beam system in itself, is seismically not very suitable per se, but of course they can be used for or they can be used in low low seismic intensity zones. All right, so what I would say, low seismic intensity zones like zone 3 in Indian context. Of course now the zones are going under a revamp in the newly launched draft. So uh, talking in the context of the older zones that we have, so up to zone 3, let's say, which are low seismic intensity zones, you can use the slab without beam systems without shear walls, I'm saying, as a intermediate moment resisting frames. Okay, right now you do not have it in the IS 13920, but I think they are going to bring it, the intermediate moment resisting frame system, very soon in the next revision of 13920. Or if you are in higher seismic zones, of course you can integrate it with shear walls. So as such, even though the slab without beam system is not quite seismically suitable, but still you can integrate it with RCC shear walls, or you can uh, use the intermediate moment resisting frame system to use the flat slabs or flat plates in the seismic zones also. Now there are quite a lot of studies that if you have slab without beam system, then the flat slab with drop system behaves better. Okay, there are a lot of studies that have been done, lot of research papers that are available on the internet, that if you have flat slabs with drops, they behave better than the flat plate systems against seismic load. Why do they behave better? Because you have a thickened drop over here, it adds to the shear resistance overall, and it adds to the stiffness at this joint. Okay, so that's why this flat slab with drop system behaves better as compared to your normal flat plates against the seismic loads. Not only that, as I told you already before, that the flat plate systems, they tend to have more seismic weight because they are bulkier, they have larger sulfates, so they will have uh, because of the larger seismic weights, they will attract more earthquake forces. If the earthquake forces are more, what will happen? The drifts for the same column sizes will be more. So flat plate systems will have a larger story drift, which means that the drift induced shear forces are increased in the columns. So at the column slab joint, which is obviously a critical joint in your beam without slab systems, the additional shear forces that are induced due to drifts, they will lead to larger shear stresses, thereby requiring larger thicknesses of your slab. Okay, so I hope you are understanding that we are getting caught in a loop whereby increasing the dead weight is adding to a lot of other issues. Okay, and because I told you more drifts, that means to safeguard your structure against the drift requirements, you have to further increase the column sizes, and also the columns which are behaving just like gravity columns, just as gravity columns, for them also you need larger sizes. So you get caught up in all these things when you provide the flat plates. Is it clear till now what I'm telling you? Yeah. So if I tell you all this, now what would you think, that which system may be better? So for that, we have a small comparative problem that we will discuss. But before that, let me just take your comments. Uh, Mr. Chinmay was saying that he thinks pure flat slab is not good for large spans. Mr. Vikas is saying if load is more, then drop is suitable. Engineer Abdul Rahim is saying in PT flat plate design using BS British standards, we have better control by column top reinforcement. Instead, in ACI punching control only by concrete. Okay, so he's talking about the two codes right now. Engineer Sushil Chaurasia is saying with flat plate systems gaining more and more popularity, clients almost always ask for it, and we have to eventually go for form over function. Very well said by Mr. Sushil. He is saying that because of the pressure of architects, it's more about architect than clients, because clients can be uh, better educated by the engineers to choose a better system, but it is more about architects, I believe. So with flat plate systems, clients always ask for it, and we have to eventually go for form over function. Very nice, very well put. Mr. Rais is joining us from Shopian, Kashmir. Is saying most architects want to reduce drops without going flat slabs in zone 5. Okay, so he's saying that they want drops, but they want to reduce the thickness of drops. Quite interesting. Let us see. So let us have a comparison of these two to understand what I'm trying to tell you. So we have taken a sample building, and it's a G plus 10 building that we are going to quickly discuss. It's going to be a 45-meter by 27-meter plan dimension. Height we have considered 44 meters above the ground level and 4 meters below the ground. 4 meter is the story height, and on all floors we have applied a dead load of 1.5 kilonewton per meter square and a live load of 4 kilonewton per meter square. Seismic zone is 3, and the response reduction factor is 3. This we have taken from the intermediate moment resisting frames, which though are not part of 13920 right now, but very soon they are going to be. So R I have taken it as equal to 3. Importance factor we have taken as 1. This is the grid plan that we have chosen, and we have placed columns at 9 meters distance, center to center. So all these are columns, and it's a simple geometry just to because we want to understand a few things. So this is how the geometry would look like, and then what else do we have? And then this is the story details. So it's a G plus 10 system. So let's compare. So the option one that I'm taking is flat slab with drops. So in this case, we have a slab with drop panels below the slab at the column locations. Yeah, so I have already told you. And we have designed the structure for dead loads, live loads, and earthquake loads we have applied using the response spectrum method, and base shear scaling and all those things we have done. I'm not going into details of that. So this is the ETABS model. that you can see, this is the floor plan for the slab with drop system. Okay, so you can see this is the slab and these are the drops. This is the column, and we have taken the one third drop panel size as per the code. So the drop panels are 3 by 3. Okay, let's see what happens next. And this is the 3D view in ETABS. So now when we analyze this, when we analyze the ETABS model, uh, so we analyzed the ETABS model, and also we made a safe model for the slab, and we did an analysis in safe also to sort of finalize the slab thicknesses and the drop panel thicknesses and the column sizes we finalized or decided in the ETABS. So after all these things, the sizes that we got were as follows. Material, oh sorry, this is M35. Okay, this is not M25, sorry. Just make this, I'm making this correction. It's not M35, it is M25. So M25 FE500 we have used. And in the slab width drop system, we could manage with a slab depth of 200 mm, and it was coming to be okay for the long term deflections also. So the slab depth we took 200, the drop thickness, the drop panel we took 350, and the overall size, clan size of your drop was 3 meter by 3 meter. So this was 200, this was 350, and the overall size of this drop panel was 3 meter by 3 meter. Okay, the column size that I required mainly at the lower levels, but I continued the same columns till the top floor. So the column size I required was 950 by 950. In the also all columns we have taken as same size, and then we just checked it in safe software also. So you can see the floor model in safe, and you can see the punching ratios. Periphery we have provided beams. You can see drops also, we have provided drops plus beam both. So there is a peripheral beam, it's 500 by 900 mm, and the internal columns are with drops. You can see the punching ratios, it's 0.82, 0.75, and so on. So the overall system looks quite okay, and I can manage it with no punching reinforcement, and we can easily go ahead with this system. Is it clear so far? Yes, yes, no. I hope this is making sense. All right. Now, any guesses what would happen in the option 2? So, this was the option 1. What happens in option 2? Yes, when we take flat plate, what do you think we may require as the our size? So, let us see. So, this was the option 2. Now, you can see there are no drops. Entire slab thickness is uniform because I cannot take the drop panels. So, it's a complete flat plate. And when we analyzed it, so of course this is the 3D elevation, and when we analyzed it, so the column sizes were finalized in ETABS, and the slab sizes were finalized in safe, after checking their punching and all that. So of course the material grade remains the same, make it M35 not 25 FE500. Now this time we had to provide a overall thickness of, uh, change it to 350 or even 360 we may require. So the overall thickness we had to provide was around 350 mm. All right, you remember what was the thickness that we provided it in the flat slab with drops? So it was a 200 mm thick. Yes, it was a 200 mm thick slabs with local drops of 350. Now here if you see the overall slab thickness has to be made 350. Okay, and the column size is 1100 by 1100. Now why did I had to increase the column size? Because the overall dead load of the system increased, because I was not supposed to provide a drop. So the overall dead load of the system increased, and because the overall dead load of the system increased, the earthquake loads increased, the gravity loads on the column increased. Therefore, to manage similar reinforcement percentage as in the earlier option, I had to increase the size to 1100 by 1100. In the earlier option, we could manage it with a 950 cross 950 size also. So this is the floor model in SAFE, and you can see that even with a 350 slab thickness, you can see the punching ratios. Okay, this is without drops, so they are almost 0.95. Somewhere they have reached 1.03 as well. And in the earlier situation, when I had provided a drop, I was at some 0.75, 0.8 punching ratio. And here I am looking at a 0.95 to 1.03 ratio. So if I can just compare to summarize, in the option 1, flat slab with drops, make it 35. The slab, I could manage it with a 200 thick slab, and the drops, 350 drops, 3 by 3 meters. Column size was 950 by 950. Compare it with your flat plate system, make it 35. So the overall thickness I required was 350, and that also will require some more punching reinforcement in the column. The column sizes themselves increased to 1100 by 1100 instead of 950 by 950. And if overall I compare the quantity, my RCC quantity alone for the superstructure comes out to be around 8050 meter cubes of concrete if I'm providing a flat plate system. And compare it with flat slab with drops, I can manage it in 5769 cubic meters. So imagine this is the quantity we are looking at just for the superstructure. So imagine the saving, even if I consider rupees 4500 per cubic meter, I can save around 1 crore rupees just in the superstructure, and that too just in the concrete. I have not even gone to calculate the reinforcement, the shuttering, and the additional substructure cost. So you can see I can actually manage quite a good saving if I'm using flat slabs with drops as compared to flat plates. Okay, so this is what I had to present for this particular segment. I hope you understood what we discussed. So the summary is that if you are going for flat plates, they are going to be quite uneconomical for you unless you do not go for the PT flat plate systems. So if you're not going for PT, then providing normal flat plates are extremely uneconomical. Okay, even if you are going for PT, in my opinion, you should always provide drop panels with them. So that adds to the stability, that adds to the that gives you a lot of deflection control, and overall it is a better system than providing flat plates. So this is what I had to tell you about this first segment. If you have any comments, questions, we can quickly take a couple of them. Otherwise, we move to the next topic of discussion. Yes, anyone has any comments? So, if you are not going for PT, what Mr. Sushil was saying, that of course flat slabs have a better form, and I mean they are better suited systems. So, as a structural engineer, if you are into some project and let's say your architect or client is insisting on flat plates, you can tell them that it is an uneconomical and an inefficient system to adopt. Okay, and finally what they do, even if you provide flat plates, most of them will provide false ceiling below it. So everything is then, I mean, there's no point that you provide flat plates if you're going to provide false ceiling below it, right? So keep these things in mind when you discuss with your clients on some project. Good. So this is what I had to tell you about this discussion. And now we will move ahead to another important point that I thought we will discuss in this particular episode. And that is that how can we practice as a freelance structural engineer. Before I go there, Mr. Chagan Kumar is asking any strength difference. No, so I see that's what we discussed. That too, if I was giving a flat plate, I have to have the overall thickness increased to 350, because if I want to have a similar strength, I have to increase the entire slab thickness uh, to that thickness. So to maintain similar strengths, I have to put in a lot of more concrete where it is not required. So I am adding to the bulk of my structure. I am adding to the dead weight of the structure, uh, without getting any structural benefits out of it. All right. Yeah. So let us come to the second discussion, and the second topic that I would like to discuss. I think it's going to be interesting. It's about the it's about practicing as freelance structural engineer. Okay, what do you mean by it? What is the meaning of freelance engineer, and why did we think that we should discuss such a thing? Let's see. So freelance structural engineer, I'll just call it as FSC to save my time. So what is freelancing in general? What is its meaning? That if a professional, let's say he or she is not permanently uh, working or associated with an individual or a company, or an organization, and instead of getting permanently associated, let's say an engineer is associated on a project to project basis, that is what we can roughly call as a freelance structural engineer. Okay, so so either the individual may be, uh, I mean, he or she may be working in, let's say, as a permanent role in some other firm, and in addition to it, also maybe working as a freelance engineer for some other projects, just to compound his or her income. So that is also possible. I know many of people who work for uh, a company as a permanent job, and in addition they do other works also, designing works or whatever. So that may be called as moonlighting, as it is, as the term goes. So either you may be working for just as a freelance engineer, or you may be associated with some firm, and additionally you may be working as uh, an FSC. So why this freelancing has gained acceptance? Because most of people post pandemic, uh, I mean, remotely working is accepted now. So in earlier days, it was only some professions that where remote working was a possibility. But after the pandemic, and even during the pandemic, a lot of structural engineering companies also switched to remote working, and that's how this thought came to many of the practicing engineers, that why to work only for one company, why cannot we work as freelance engineers. So therefore it has gained uh, quite a lot of acceptance these days, as remote working is, I mean, it's quite an agreeable thing to do these days. So before I move ahead, why did this issue come up for discussion? So recently in our company, where our consultancy firm, we were appointed as structural engineers for a project which was involving large flat slab systems, and that's how this first topic for discussion also came up, where I discussed about the flat slabs with drops and flat plates. So that thought also came to me during this project only. Anyway, so recently we started doing this, and at an individual level, me and Akanksha is my wife, so we were at IIT Roorkee together, and then she worked at ACOM Dar Consultants, and I also worked at Dar Consultants. So we had the experience of working on large flat slab projects, large commercial flat slab buildings, multi-storied buildings, all those things. But in our consultancy firm, our staff did not have the necessary experience. So we had the experience as an individual, but our other staff members did not have the necessary experience to do this project. Of course, we are doing it now without any problem. But then that is when we thought that why not to look for some freelance engineer who could help us on this project, and the appointment will be on a project to project basis. Okay, so that's how this entire thought came about. And then I looked into this issue in more detail, and that's what we are discussing right now. So, advantages of working as a freelance structural engineer. So, in my to my mind, what are the advantages of working as a freelance engineer? Before I move ahead, anyone in the audience who works as a freelance engineer anywhere, or who has been associated with, uh, who has been associated with organizations on a project to project basis? Anyone in the audience? Okay, no one. So everyone who is in the audience right now, uh, none of them seems to be working as freelance engineer anywhere. Anyway, so what are the advantages that I thought? That first of all, in my opinion, it is economical for the employer to hire a freelance structural engineer. Uh, Mr. Sushil is saying he has done some freelancing a few times for small residential projects. Interesting. We will like to hear more from you about your experiences. Engineer Abdul Rahim has also worked for some projects as freelance engineers. Quite okay. So yeah. So what are the advantages I think of working as a freelance engineer? Uh, so see, first of all, I think it's economical for the employer to hire a FSC freelance engineer because you get to hire, of course, for a project basis, people who are having specific experience suitable for a particular project. So you can bring those people on board. And uh, I mean, because it's a project to project basis, you don't have to spend a lot, and people are on board with you. Okay, so the employer does not necessarily need to maintain a large number of staff, and the hiring can be need based, and this actually helps you in reducing the operational costs. So if you have to maintain a large staff, you have to pay them salary, and therefore the operational costs go up. Okay, so this is from the viewpoint of an employer who is going to ask for services of a freelance engineer. Now, what are the advantages for a person who is going to work as a freelance engineer? So he or she can be associated with multiple employers at the same time. Okay, so it's not necessary that you only work for one project at a time as freelance engineer. You may work on several projects with several different agencies, right? So you can compound your revenue generation by working for multiple people. And as we discussed, that it's quite okay these days to work from home, even for structural engineers. So a freelance engineer may get the luxury of working from home, and thereby the overhead expenses reduce. So let's say you have to move to a different city, and then you have to join a job. So you have to move there, you have to rent some space, you have to live there. So of course you are spending more money. So if you get the luxury of working from home, or working from not going to the office physically, of course it will reduce your expenses. And because if you are working as a freelance engineer, geographical proximity is not a hindrance. So you can sit in Indore, and you may be working for some project in Europe, let's say. You can quite easily work as freelance engineers. So geographical proximity is it does not remain a hindrance. All right. So I think these are the advantages of working as freelance structural engineers for any project. Of course, there are some disadvantages also, and that is also what I would like to discuss. Uh, so, in my view, the disadvantages right now, or the limitations right now, are that how to search for freelance structural engineers who are well suited. That is the biggest challenge for the employer right now. Okay, so as I told you, suppose I have a project. Let's say I have a pedestrian bridge project. Now, how to search and where to search? how to search for people who have specific experience in working in steel pedestrian bridges, let's say. So searching people is the biggest challenge for the employer, one who is going to hire the freelance engineers. For the freelance engineers, what is the problem? How to search for the projects. Okay, so on one hand, employer is searching for people, and on the other hand, the engineer is searching for projects. Okay, so that is a big roadblock, what I think, in the for the freelancing engineers. Then also one more thing that I feel is a problem can be the day-to-day coordination and monitoring. So for projects which involve intense coordination with multiple trades, let's say you are working on a commercial project and there are a lot of services uh, with whom you have to coordinate. So working as a freelance engineer may involve some coordination problems, and monitoring by the employer, that may also be a problem. And because it is more because we as structural engineers, we are not used to working remotely, as people from other professions uh, are quite comfortable these days, right? So if you look into any job in the IT, telecom, or computer science, data analytics, finance, so many of them work quite comfortably remotely also. But right now, because structural engineers don't have the uh, necessary experience of working remotely, I will say that we are not acquainted to work remotely, and that can be a big hurdle for the freelance engineer also, and even for the employer. Then of course the bigger problem is the issue of site visits. So for projects which involve site visits, uh, we still have to understand some mechanism, uh, some way to develop a mechanism that your structural engineer can have a uh, how he or she may have a frequent site visit. Okay, and of course some minor issues can be the issue of confidentiality, how to maintain data security. Those are also issues. They may not be that big, but yeah, those are also some minor issues which we have to think about. So but yeah, I think in my opinion the biggest limitation is creating an ecosystem for the freelance structural engineer. So what do I mean by ecosystem? That one who is the employer, one who is looking for freelance engineers, he or she should get suitable freelance structural engineer, and one who is working as a freelance engineer, he or she should get a suitable project that he or she wants to work on. So I think this ecosystem is a big problem. And right now I do not know how to search for engineers. Let's say if I want to give some project to uh, an uh, an engineer on a project to project basis, right now I do not know uh, how to do that. So this according to me is the biggest challenge that we have in front of us in working as freelance engineers, that there is lack of ecosystem. So how do the employer find a suitable freelance engineer, and how the freelance engineer look for project? So this is the biggest hurdle, and I think what should be done. This is what I actually wanted to discuss. So I also don't have any. Uh, I mean, I also don't have anything to say over here because this was a problem that I faced. Yeah. So so let us discuss for next 5 6 minutes, and from the audience themselves, let us try to understand that what can be some ways to develop an ecosystem for this, and what are the challenges and roadblocks that the people who want to hire freelance engineers face, and those people who are working as freelance engineers, what are some of the challenges that they face. So let us discuss for 3 4 minutes, 5 minutes, and then we will move ahead to our next segment. So, yes, as I told you, Mr. Sushil, he just said that he has been working on residential projects as freelance engineers, and Mr. Abdul Rahim is also working on projects as a freelance engineer, and he is involved in projects involving concrete strengthening. So Mr. Sushil is saying freelancing has allowed him to network with other engineers, but sometimes it has also been difficult to keep up urgent requirement parallelly with a full-time job. Yeah. So if you are doing a full-time job, it might be difficult to do projects as a freelance engineer. I do agree. Mr. Rais is saying how to work globally as freelance structural engineers. Yeah, that is what I am also thinking, that how to open up avenues and how to work globally for global projects as freelance engineers. Mr. Sushil has raised a very good point. He's saying that as an individual, it is quite prohibitive to buy expensive software licenses. Okay, so because there are you don't get affordable individual plans, it becomes prohibitive to buy software licenses, let's say for just one project. But over here I would like to add that now most of the software companies, they come up with monthly or quarterly licenses. So uh, let's say you are working on a project X. So for that project X, you just go and buy a license, let's say for quarterly license. Okay, and when your project is done, it's over. If you again get some project in the future, you can again buy the license. So I think that those options are now prevalent, where the software companies have understood, or you can buy them on a rental basis, monthly rents. So almost all the softwares now have turned into rental basis from the perpetual licensing plans. So earlier they used to sell their software license for lifetime. Now they sell it for yearly or quarterly basis. So I think that gets taken care of. Okay. Yes. Anyone wants to add over here that what can be a system that may be thought of, where all the freelance engineers are on one platform, and let us say if any employer is looking for freelance engineer, he or she gets them easily from that platform according to the required experience. Yes. Anyone has any comments on it? So I think right now LinkedIn was one of the options that I could see, or uh, community groups on, let's say, Telegram or LinkedIn, where you just put your requirement and then people may approach you. So right now the only platform that I could see was that of LinkedIn, but there has to be a dedicated platform where this demand supply is matched. All right. So if you have a good platform, if you have a good arrangement from where you can get freelance engineers, I think this trend of giving projects to freelance engineers will also increase, and it will be a beneficial situation for the practicing engineers, that they can easily work as a freelance engineer and increase their revenues. Good. So I think this is a topic which needs more brainstorming. So I'll continue to think on it, and let's see if we can develop some platform for this type of a. I mean, we can develop a platform to cater to this freelance engineering ecosystem. Anyway, so this is what I had to tell you. Mr. Sushil is saying software companies could create regional plans for individuals. Buying renting licenses in USD is often not viable, and some companies are trying to catch up. Uh, yeah, creating regional plans. No, I think most of the companies do have regional plans. Most of the big companies do have regional plans. They don't ask you to buy in USDs. I mean, if you look at Bentley or CSI, you can take licenses in Indian, let's say only for the Indian code, pay in the Indian rupees. I think that is there. Good. So I think we had a good discussion. So I'll quickly move to the next segment. And as you all know, in this next segment, we invite young engineers who are working, and we try to learn from their experiences and try to understand how their journey has been, and try to I mean try to learn from their experiences. So this time we have invited engineer Ishita Kalsi. She is a graduate in civil engineering, and then she did post graduation in structures from NIT Agartala, and she subsequently worked for a couple of different companies, which I think she will tell us more about. Presently, she is a senior design engineer at Kalpataru Power Transmission Limited, and she is working in Mumbai right now. She is involved in design of industrial and residential structures. So we are very happy to have her in the audience today, in the episode today as guest engineer. So presenting to you, Engineer Ishita. Thank you for joining and welcome to this episode.
Good evening, sir. Thank you for inviting me to be a part of this series.
Thank you. Thank you so much. So sorry for the delay because I think you had to wait for a long time. But yeah.
It's okay, sir.
So
I found the discussion very interesting. So I was enjoying.
okay, thank you. Okay, good. So yeah, tell us about something that what you did when once you, I mean, after your engineering, what you have been doing. If you could tell us a few things
Yes,
about
sir.
it.
So I did my BE from Jabalpur and then I prepared for GATE and I did my master's from NIT Agartala in structural engineering. And from there, I got campus placement in KC International, and in that company in KC International, I was given the designation of a PGELT, that is postgraduate leadership engineering trainee. So in
Okay.
that training tenure, we were exposed to a lot of various fields, as in we were given site trainings, design trainings, marketing and business development trainings. So it was quite diversified.
Yeah.
And in the marketing and business development training especially, we were explained what are contracts, what is the bidding process, and
Hmm.
what is an EPC contract, item rate contract. Of course we have learned about these things in our colleges, but when you do an actual project, when you see the technicalities and the minor things that need to be considered before bidding, so it becomes much more interesting.
Yeah.
And then I was in the site training. I was placed in Rajkot, Gujarat, where I was part of an EPC project. It was a railway overhead electrification project, very vast site. So there we were exposed to the difficulties and technicalities faced by the site team, because although the structure engineer will be designing in the future, but they must be aware of the difficulties that the site engineer experiences. Then only
True.
it will be an efficient design, else it's very difficult.
Yeah.
So there we learned about the importance of EPC contract. As in EPC contracts, our sir used to say time is money, because it is extremely important to finish the milestone and before the deadline, because the penalties are such high that
Yeah.
the company will face huge losses.
Correct.
So in detail we learned what is an EPC contract. We were part of that, and then we also learned about resource management, because the site was very vast and multiple construction activities were going on at the same time. So the project manager had to manage resource, labors, materials, and all those things, and we were involved in that part. So that was quite good to know how the management is done at site, and the importance of like soil investigation before bidding the process. So the
Correct.
importance of how a detailed site investigation should be done, because sometimes what happened is that, say, the soil was identified as clay, and then when the activity is actually started at site, so after some depth of achieving clay soil, there's sudden hard stratum rock, and
Yeah.
that was not estimated before. And then you need equipments, you need extra labor forces, and there's a huge delay in the project.
Correct.
So that is also very crucial.
Yeah. Yeah, I have seen some projects which, due to lack of proper investigations, went into a lot of losses and lot of delays, as you just mentioned. True.
Yeah.
So KEC is also involved in, I think, solar EPC. They also do solar EPC.
Yes, sir. It's a very like I was specifically in the railway business unit, but it has other
Okay.
departments also.
Okay.
So there are various departments there.
Okay. Good. So you worked in KEC for how long?
Sir, I was a trainee and I worked there for almost an year.
Okay.
And then I wanted to be more into a designing company.
Yeah.
So I switched. So then I went to KPTL, Kalpatru Power Transmission Limited.
Okay. So that is your present company right now.
Yes, sir.
Okay. So tell us about the type of work that you do and what are your roles and responsibilities in the company right now.
Yes. So I am a senior design engineer at KPTL. It was earlier JMC projects, but now it's merged with Kalpatru groups.
Okay.
So here my role involves designing of structure, both pre-bid and post-bid GFC stages,
Hmm.
coordination with clients, coordination with the architectural team, estimation team, draftsmen, and the
Yeah.
site team as well. So here, actually, it's an mix of both management and design job. So the work profile is very good, and I've been exposed to different types of projects here. So, for example, there was a hospital building that uh, we were doing. So there, the client. So now the NDMA guidelines have to be followed for hospital and important buildings.
Yeah.
So the NDMA guidelines suggest the criteria of 4% shear walls. So which
Okay.
was very expensive, very uneconomical. So the
Hmm.
client suggested a new technology, a new lateral resisting system that was YRB, yield restraint bracing. So that
Yeah.
was a very new concept because in India also you will not find many vendors practicing YRB at construction sites. So by using YRB, what benefit we can use is the all the lateral forces which were earlier attracted by the columns and the shear walls, specifically the shear walls, because shear walls are the stiffest members in the building, and the stiffer the member, the higher force it will attract.
Yeah.
So, and then if the shear walls are attracting higher forces, then we have to design the length and width of the shear wall accordingly so that they don't fail, which was
Yeah.
making our project quite expensive. So
Okay.
we introduced the concept of YRB in the building. So what these yield restraint bracing do, they attract all the lateral forces, and
Uh,
so the need of shear wall becomes less. And so we came up with a building with zero shear walls and only YRBs and columns.
okay.
And what the advantage was that if we use yield strength bracing, and the response reduction factor can be used as 6, which is not given in our code. We have
Correct.
5. We have so
Yeah.
after using R6, the forces automatically reduce. The reduction factor is high, and so the structure becomes light.
Yeah.
And yield strength bracing automatically makes the structure more ductile.
Okay.
So which was
Uh,
beneficial.
yeah. So this was one of your projects that you did or are doing right now, or you
Yes, sir.
have done.
We have like it was in a pre-bid stage, but
Okay.
we so for the YRB there are not a lot of vendors, so we
Uh,
hired a vendor, like outsourced a vendor, and so currently actually then you will find only 4 5 projects in India that are using YRB, so it's not very
yeah.
common
Yeah.
now. It may be because the
Uh,
NDMA guidelines are now made mandatory.
okay.
So
So NDMA guidelines now require the bracings to be provided. Is that what you're saying?
yes, yes, yes.
Oh,
So
okay.
YRB, either you provide sufficient number of shear walls,
Okay.
or you can go for NDMA guidelines want the structure to be more ductile, as in. So
Uh,
they suggest you either use shear walls, or then the client only suggested what you can do is instead of shear wall you can also go for YRBs. So they
okay.
introduced this concept to us.
Acha. So are
Hmm.
there any design codes right now, design standards in the Indian context, or you had to use international standards for it?
So they're not in the Indian context as of now, and
Okay.
also it's been given to another vendor, another consultancy for the
Okay.
design.
All
and
right.
the discussions will happen in the later stages, and then we'll know more about how they're designing it. As far
Okay.
as we know now is they are using springs, assigning them stiffness, and
Uh,
using them in the bracings. So
uh.
that is what IRBs are.
So they are yield resistant bracings. Yield.
Yes.
Okay. Interesting. So you are saying there are only three or four projects right now in the country, those who have used YRBs as a lateral load resisting system.
Yes, as far as I'm aware of, there aren't
Okay.
many projects
Okay.
that are using YRBs.
All right. Quite interesting. Yeah. So, any other interesting project that you have done in your present organization?
Yes, sir. So one more project. It is an international airport. It is outside India, and so what was the issue that we were facing was that the roof of the airport was very irregular,
Hmm.
and the code suggests two types of roofs, mainly curved and pitched roof,
Yeah.
and our roof is none of that. It is highly undulated, and it is like it is not at all regular from any elevation section, plan view, anything.
Yeah.
So what challenges we were facing was that what pressure coefficients to apply on that roof,
Yeah.
because wind was the critical factor there.
This is in.
So
Where did you tell this? This project is in.
it is in Maldives.
Acha. So it's on right on the sea. I mean, it's an island, so it
Yeah.
experiences extremely high winds,
Yes, sir.
and
So
I think a lot
wind.
of cyclones also.
Yeah, yeah,
Yeah.
yeah. So cyclonic factor 1.3.
Acha. Please continue.
so
So you were saying,
so the challenges were what pressure coefficients to apply, and in order to find the coefficients, you have to do wind tunnel testing,
hmm,
and or then we outsource another consultancy
hmm.
who performed CFD, computational fluid dynamics,
Okay.
on that roof profile.
Right.
And in our code, we use four directions for wind applications, right? Wind
Hmm.
x, minus x, plus y, and minus y.
Hmm.
But since the roof geometry was so complex, so had to take eight directions. So at every 45 angle, we have to take directions and
Yeah.
apply wind and get the reactions. And the most critical cases we got, then we transferred that load to our columns and then analyzed the structure. The working is still going on,
Yeah.
and so that was a very new concept to me,
Uh,
the CFD analysis. It was done in ANSYS by the
okay.
consultancy.
Okay. Quite
Hmm.
interesting. So other than that, how does your daily day look like? I mean, you are involved in designs right now. So what type of systems do you use for design? What softwares do you use for design? If you could tell us more about it.
Yes, sir. So yes, I'm involved in design of buildings and factories and industrial structures. So we mainly use ETABS and STAD for that. And for foundation design, we use SAFE, RCDC,
Okay.
and even for like proof checking our design, and for slab design, and we have prepared Excel sheets as well. For
Okay.
staircase design, we use Excel sheets. And it's more of like what I understood after working here is that we have to go by the architectural drawing first. Whatever the architecture says, we have to try and abide that
Yeah.
okay, if he wants the column not to be more than 900 dia, so we cannot give. So we have to you know work from our sides and somehow make the structure safe.
Yeah.
And then coordination with the architectural team is very important. Coordination with the estimation team is very important, because
Mm.
ultimately when you bid a project, money and other things are very important. And
Yeah.
coordination with the draftsmen, and there has to be proper bonding, proper communication skills, and proper communication within the team to
Mm.
in order to get a efficient result. So
Yeah.
that I learned working in like in KPTL, how important team management is, how important good communication skills are, and how important is it to represent yourself in the client meetings and all those things.
Yeah.
So that was also a good learning experience here. Also, sir, I
Okay.
would like to add a lot of data center projects are now going on, and
Oh,
so
okay. Data
a lot of
center as
data.
in data centers. servers. Those act as the servers for your
Yes,
large
yes, data center
internet.
buildings,
Okay.
very like G plus 10 story data centers projects, and a lot of companies I've seen, the data center, the if an engineer can design data center, then they are of high demand.
Acha.
So we also did a like pre-bid now, design stage for a data center,
Uh,
and the design was quite different, as in there were a lot of heavy loads in the
mhm.
stack rooms and all those things, a lot of false flooring, a lot of sunk slabs,
Yeah.
and so also the construction was composite, as in up to the plinth level it was RCC column, and above that it was steel columns. So
Okay.
that was also different. And then the client has some demands, as if the column should only resist, if it's a RCC structure, then the shear wall should resist 75% of the lateral load,
Uh,
and the column to moment capacity should be 2 and not 1.4. So all these new things clients keep adding, and then we have to make it work somehow.
yeah.
So yes,
Interesting. So this
yes,
is steel above and it is RCC below. Steel structure
yes.
above the ground. Okay. And what do they do for heat load? Because there's extreme high heat loads that are generated from these servers.
Yeah, yeah. So temperature, yeah, heat load. That was not considered in the pre-bid stage, as in
Okay.
the. But other than that, now what the client has now, that they want us to consider temperature loads. So
Ah,
that, and so there is a bit of um, difficulty in, because initially we used to consider temperature loads only in the serviceable load combination, and
ah,
then some codes suggest take it in the ultimate load combinations as well, and
hmm,
so a lot of confusion happens for that.
yeah, true. So what do you like more, working on site or working in a design office?
I like working in the design office,
Okay.
but yes, I like to get involved in site coordination because it is very important.
Yeah.
And as seniors, they also keep saying us to go and visit sites so that we expand our knowledge. And in order to grow more as a structural engineer, also one has to have a good design knowledge, because ultimately then we'll go up to project manager and all those levels. And for that,
Hmm,
site experience is a must.
true. Quite right. If our audience has any questions for Ishita, they can just type in their questions in the comments, and we will take up your questions. Good. So, what are your future plans? What are your, uh, I mean, what do you want to learn more, or what do you want to do in the future?
Sir, I would like to definitely diversify my experience in structural engineering, because it's such a vast field that even after lot of years of experience, there will be something new, some latest technology, some new device, base isolation, some new uh, kind of construction method that will keep coming up, and you have
Yeah,
to continuously update your knowledge.
yeah,
So it's actually, that's why it's a very interesting field, because you have to continuously, learn and get used to new things. So
true.
just for example, YRB, this was the first time I ever heard of YRB, and
Yeah,
it was quite new. It is still quite new in India, but
mm,
once I've learned it, so now I'll be able to apply it in other projects without client suggesting it. I can suggest it first to
yeah,
win the project, win the bidding, because my design will be uh, comparatively less expensive than other consultancies design.
yeah,
So, and so I would also like to learn bridge design and other things. And so one like observation I have made is that if you are a structural engineer and you want to stand apart from the crowd, so
yeah.
some knowledge of coding, visual basic, and
Correct.
good command of AutoCAD
Ah,
is actually very important, because you can do wonders with coding and Excel if you get
correct.
a good command over it.
I know.
So that is
I think.
very
Yeah,
AutoCAD, one should be, the structure engineer should be not if as good, but still very good, not as good as draftsman, but still very good at it, because
Yeah.
every time you cannot go to the draftsman and say just check this shear wall thickness will fit in the architectural plan.
Uh,
Can I do this? Can I get this? So
correct.
that is also very important.
Yes, I think you have raised a good couple of points that not only design, but you should also be good at AutoCAD. And yes, Excel, I think it is one of the most powerful softwares that we have. So
Yes.
learning Excel, learning a little bit of Visual Basic based coding, I think it is quite important, quite useful if you have those skills.
You can do wonders with the MDB file you get from eTabs in Excel. You can do
Yeah.
wonders.
And I think people nowadays are using Chat GPT and they are generating Excel coding programs and then they're doing a lot of things. Rahul, I think he's
Yes.
in the audience. Rahul Brijpuria, he does a lot of things with Chat GPT and taking some codes from there and generating some Excels from that. Yeah.
Yes.
So, uh, Mr. Sushil wants to know how has been your experience so far. And okay, so he is asking the same thing, that which one do you prefer, site or design?
Okay. Yeah, I prefer design, but I also want to have a fair share of experience at site as well, because for a design engineer, both are equally important. You need to know the technicalities and the difficulties that the site engineer experiences, and after only after learning that you can design in a more efficient way.
True. Mr. Krishna Radhe wants to know that when you did the data center structures, did you design them according to the ductile design provisions of Section 12 of IS 800 2007?
So it's actually totally on the basis of on the requirement of the client. So I was not involved in the design of this data center, so I
Okay.
cannot. But there are certain requirements that you have to fulfill, and as per
Okay.
that, the client requirements, you have to do the design. So
So
that
are
is.
they only client requirements, or there are some standard documents that are nowadays available which are used as a design basis?
So there are some standard documents, but for the data centers, we as of now don't have any.
Okay.
But I'm
India
sure if
does
there
not
are a
have.
lot of projects coming on, then there will be some standardized documents developed for that.
Okay. So right now, when you were doing it, your team used the international standardized documents that are there for the data centers.
Yeah, both. It's actually the client specifies the code. So according to that only, they provides a DBR as well, their structural
Okay.
DBR. And
Okay.
with respect to that, we have to design.
Understood. Mr. Digant Dubey wants to know how do they fix steel structure above the concrete structure? Do they? Okay, so he is asking that do you fix? Do they go on existing columns or is there anything else? I think he wants to know how do you fix the steel columns to the RCC structure below.
So
So
there's base plate, there's a connection design proper for that.
yeah,
There's
I
base
think he
plate.
wants to know whether you. I mean, it's a generalized question, so let me answer. He's saying that do you put it on a base plate? That's what I understand, or you directly embed the steel concrete inside the RCC pedestal. So I think both is done. You can even embed the steel column directly inside the RCC pedestal, but then that adds to the cost. So most of times we will fix a base plate, and on the base plate we will fix up our steel column, and then that base plate in turn is attached to the pedestal below. So you can do what you are saying, embedding the entire steel column inside the RCC, but then it adds to the cost, so we usually avoid it. But in the solar structures that your earlier company was doing, in these solar structures, utility scale power plants that they set up, they generally embed the entire steel column inside the RCC pedestal. So that saves their time over there. Because as you said, time is of large importance. So to save the time, they do it that way.
Okay.
Yeah.
But for the data center here, we did a proper connection based design for that.
Okay.
Yeah.
Interesting. Any other questions we have? Okay. So, any message you want to give to the audience? Most of them are young engineers, young practicing engineers. So, any message you want to give to the audience in the end?
Yeah, for all the young practicing structural engineers like me, I'll just give you an advice that I relate to the most. So, apart, of course, good technical knowledge is very, very, very important. But apart from that, try and have good networks, do good networking within your office, go on LinkedIn, make contacts, try and get, try and be updated with the latest technology that are coming, as in learn coding. I feel in the future a lot of things will be automated, and the one who has a good command of programming languages will be a better structural engineer than others. And also try and have a good rapport with your team, as in have good communication skills, because proper communication is very important within the and the QS team. A little mismatch, a little error in the communication can really do blunders in the project. So from my experience, I'm telling you this.
You ended up doing some blunders.
Yeah, so there was, like, I was interacting, I was with the estimation team, and I
Uh,
just told the member that I have saved the new quantity. Please take it from that folder in the server.
uh,
And she did not respond yes. And I thought
uh,
she's heard it. She's on the
okay.
other side of the table. And then I resumed my work. And
Uh,
then she sent another file to the client. And
oh,
so that was a really big blunder. So that my learning was to always check the mail before anybody sends it.
yeah. True. Mr. Krishna wants to know if you can share some pictures of buckling restraint brace connection with RCC if possible.
I
Or you
don't
can,
have as of now.
yeah. Perhaps you can
You can,
just from the internet you might get some images maybe.
yeah, you can Google it and you will find buckling restraint bracing.
Mr. Chinmay wants to know which coding language should we learn according to you. Yeah.
Let's start with VBA first. VBA is very important, Visual Basic Analysis in Excel. And then you can decide which language suits you. There are a lot of Python and other languages. You decide what language is like easy for you, and then you have to do coding. You have to do automation basically. So it can be done in n number of languages, right?
Hmm. Mr. Swaroop wants to know, please tell us which codes you used for the YRB.
So since we did not design the YRB, we have actually outsourced it to another consultancy. So, and the meetings are still going on. So I am not familiar with the code that they have used.
Hmm.
So my apologies.
So it's a Canadian company you are going to do the YRB project,
Yeah,
right?
it's a Canadian company. Canadian
Okay.
company.
Okay. Very good. So thank you, Ishita, for taking out time and joining us for this episode. Nice to have you over here. And yeah, we
Thank you
had a
for
good
calling me, sir.
conversation. Yeah. Thank you. Bye bye.
Bye.
So we had a very good conversation with Ishita. And if there are any other questions, Mr. Santosh was asking, is there any platform to work as a freelance structural engineer? Yeah, so that is what I am also, I mean, thinking about, that what can be a good platform where the freelance structural engineers can uh, associate with each other, and from where even an employer can hire people as freelance engineers. So that is what I also do not know, and that is what I said, that we may have to develop an ecosystem for it. Right now I think LinkedIn is the only platform where you have a lot of practicing professional engineers who are using that social media. So I think for the timing, it is one of the better platforms that you have. Other than that, I'm not quite sure uh, which is the platform. If there are some suggestions how such type of platform can be created, it would be a discussion which we can have. Yeah, thank you, Mr. Sushil, for joining, and thank you all. So I think that is it. What we have for this episode. Mr. Abdul Rahim is saying, as structural engineers, we should learn Python coding in future. Yeah, I mean, coding is one thing that should be learned. Unfortunately, we did not have much coding experience when we were doing engineering. But then later on, I can do some VBA and some work in Excel, but hardcore coding, I also do not know. But I think we should learn. So it's quite well pointed out by Ishita also, and now in the audience, Mr. Abdul Rahim is also saying that as a structural engineer, Python should be uh, is the coding language for the future. Mr. Rohan is saying I am confused between the field of structural engineer and estimation valuer. Huh? I am confused between the field of structural engineer estimation valuer field after engineering. Oh, so he wants to know, he's confused about the structure, working as a structural engineer and working uh, as a certified valuer or in the field of estimation. Yeah, of course, working as a valuer also has a lot of importance these days because there are many projects for which you need to do the valuation. So typically, let's say if a project wants to apply for certain loans from any financial institution, they require some valuation and estimation. So typically, these things are, I mean, generally a chartered accountant does it. But let's say if you are an engineer who also understands valuation, so I think you will be in a better position to do the valuation work. Not only for this, of course, valuation services are sought for any new project that comes up in preparing the entire valuation scheme and other cost aspects. So, yes, valuation is also a very important field, and many of the engineers work as valuers in their entire career. So, yeah, valuation is quite important, especially if you want to act as a bridge between the financial institutions and the technical side of civil engineering projects. Mr. Ehsan Khan is saying, what do you think about Grasshopper Rhino future in view of structural engineering? Neither I have heard about Grasshopper nor I know anything about Rhino future. So I don't have any. Uh, I mean, I have no idea about Grasshopper Rhino. What this means? So if anyone in the audience can perhaps throw some light, because I am absolutely clueless about it. Yeah, Mr. Sushil is saying in his full-time job, I do majority of BIM automation and collaborate with multiple disciplines to automate AutoCAD. Just like VBA and Excel, you can automate using VBA and AutoCAD. Yeah, yeah. I think most of the times, if you know VBA in the present civil engineering softwares, most of your work gets done. Okay, so I agree. Maybe Python not required right now, but if you know VBA, you can develop a lot of macros, and these macros work on ETABS, they work on STAT, they work on AutoCAD, they work on Excel. So these macros can be integrated quite easily with these softwares. So maybe Python you do not understand, but this basic level VBA, uh, you can I mean you can learn more about it. Quite interesting. Yeah. So I think we have that is all for this episode. We had a good discussion this episode. I hope you found this interesting. So thank you to all of you for taking out time on a weekend and joining us live. And also thanks to those who are going to watch this episode on YouTube later on or LinkedIn later on. So once again, thank you, and we'll be back with another episode, and we'll conduct one more episode this month because in the last month we could not have any. So that's all. Bye bye. Have a good night and have a good weekend. Thanks for your time. Bye bye.